Hello friends, in today's video we'll look into the algorithms that we can use to obtain a minimum spanning tree. So this is a given graph. Now from this graph I want to find out its minimum spanning tree. So for that in this video I'm going to explain the first algorithm, which is known as the Prim's algorithm. So step 1 of Prim's algorithm says that we have to remove all self loops and parallel edges. Now first of all, let's see what are self loops and parallel edges. Can you see this particular edge? It is connecting vertex F to itself. So such type of a edge is known as a self loop. Okay. So first of all, we have to remove this. So while computing or while finding out the minimum spanning tree, we should not consider this particular edge. Second, let's see what is parallel edge. Now between node B and D, there are two edges. So we have to remove one of the two edges, and see, since we are finding the minimum spanning tree, it is obvious that we are going to remove the edge with more weight, with the higher weight. So we are going to remove this particular edge. So this edge we are not going to consider, and also we are not going to consider this particular edge. Correct? Now to find out the minimum spanning tree corresponding to this graph, we can start with any edge if it is not given to us explicitly that which node we must consider. So we can consider any vertex. Okay. So see, I'll just zoom out a bit. Okay. So now let's say we are using A as the starting vertex. Okay. So at the first instance, what all options we have? Since A is the starting vertex, so what you can see that from A, you can either select vertex AB, which has weight 7, or you can select vertex AC, which has weight 8. Correct? Now we are going to select the edge with the least weight. So we select AB. So we can draw AB with edge weight 7. Now after this, what all options do you have? See. Now you have reached from A to B. Correct? So the options that you have here is, from the given graph you can find out. You can either select BD with edge weight 6, or we can select BC with edge weight 3. Okay, or you can select AC with edge weight 8. See, considering this option is also important. You cannot say that since we have moved from A to B, you cannot select AC now. AC is always an option. See, for example, instead of 8, the weight here would have been, see, this 3 would have been 8. Okay, and this is also 8. So in this case, you could have either selected BC or even AC. Okay, but since given the current situation, we find that BC has the least weight among all the three options. Therefore, we will select BC. Let's draw it like this. Now, after this, what all options do I have to traverse next? See, You still have the option of BD with edge weight 6, AC as edge weight 8. Okay. Then you have the option of, now since you have come to C also, now CD with edge weight 4 or CE with edge weight 3. Now see, under any circumstance, say this had been the least weight, still you cannot now consider AC. Can you tell me why? Because if you draw this AC, this is going to form a loop here, and that is not allowed in a minimum spanning tree. Okay. So that's why we cannot consider AC anymore. So we remove this from our list. Now which is the edge with the smallest weight? It is CE. So I select CE with the smallest edge weight. Now let's see, I'm just erasing these. Now what are my options? See, I cannot consider AC because of formation of loop. So let's not consider it anymore. So after this, I can either select BD because I haven't traversed till D right till yet. So I can consider BD with edge weight 6, or I have CD with edge weight 4. CE we have already used. Okay. Now I can have either ED with edge weight 2, or I can select EF with edge weight 2. Correct? Now if you try to find out the edges with the least weight, you will see that there are 2 edges with equal but smallest weights, which are ED and EF. So we can select either of them. Either you can select ED or you can select EF. Both are going to be correct. Now say for example, I am selecting ED, or say I am selecting EF. Okay. So I am going to draw EF with edge weight 2. Now see, we haven't reached D, and D is disconnected from the graph. So I have to reach D. I cannot leave it like this and call this as a minimum spanning tree. This is not at all a spanning tree. So no question of calling this as a minimum spanning tree. Okay. So to ensure that all the vertices are connected, we have to reach D. So after this particular condition, how can we reach? What are the possibilities? See, either I can draw BD with edge weight 6, or I can draw ED with edge weight 2, or I can draw FD with edge weight 5. Now among these, the least is this one. So we are going to draw this as 2. Clear? Now this is the given minimum spanning tree. Okay. Now this is the minimum spanning tree corresponding to the given graph, which is this. Okay. Now if you are asked to find out the cost of the minimum spanning tree, can you tell me what will be the cost of the minimum spanning tree here? It will be sum of all the edge weights of the minimum spanning tree. So what is the weight of AB? So the cost will be like this. Okay. So what is the cost of AB? It is 7 plus BC is 3 plus CE is 3 plus ED is 2 and EF is also 2. So 10 plus 3 13 plus 2 15 plus 2 17. So 17 is the cost of the minimum spanning tree of the given graph using Prim's algorithm. Okay, I hope this algorithm is clear to you all. Now we want to find the minimum spanning tree and its cost of the given graph using Kruskal's algorithm. So if we see the Kruskal's algorithm step by step, the first step in Kruskal's algorithm is same as that in Prim's, which says that we have to remove the loops, self loops, and the parallel edges. So this is a self loop. I have explained what is a self loop and what are parallel edges in my previous video, where I have explained about Prim's algorithm. So you can refer that if you have not seen it. So this is a self loop. So I am not going to consider this while creating my minimum spanning tree. And this is a pair of, see, this and this edge. These are parallel edges. So we are going to remove the edge with the higher weight. Okay. Now see, after this step, what happens in Kruskal's algorithm is, see, first of all, as we did in the previous Prim's algorithm, that let's draw all the vertices, because even though we want to make the minimum spanning tree, we have to include all the vertices. No vertex should be left disconnected. Correct? So we have drawn it like this. Now, in Kruskal's algorithm, we arrange all the edges in increasing order. Okay. So I'll just write down the edges in the increasing order. So which is the edge with the least weight? It can either be DE, weight 2, or EF. Okay. You can also write it in an interchanged way. That's fine. After 2, let's look at the edges with weight 3. So they are BC with weight 3 or CE with weight 3. Again, these both might be interchanged. It is allowed. If not, then also it is okay. Next, let's write down the edge with weight 4. It is CD with weight 4. After that, edge with weight 5 is DF with 5. Then we have BD with edge weight as 6. Then we have AB with edge weight 7. And then we have AC with edge weight 8. Okay. Now Kruskal algorithm says that first we have to arrange the edges in increasing order. So this is where we have arranged the edges in increasing order. I hope you all agree with this. Now the next step is putting these edges one by one, starting from top to the bottom, in such a way that no cycle is formed. Okay. So let's just see. So let's pick up the edge with the least weight. So I am picking up DE. You can also pick up EF. Okay. I am picking up DE. Edge weight 2. Next I have to pick up EF with edge weight 2. Okay. Now let's pick up BC with edge weight 3. Then we'll pick CE with edge weight 3. Then we have to pick up CD with edge weight 4. Now should we pick this up? Say for example we take CD with edge weight 4. So isn't it forming a cycle? Can you see a cycle being formed between these 3 nodes? Yes. So we cannot pick up this edge. So I am just removing this edge. We cannot pick it up. Because if we pick up and put this edge into the minimum spanning tree, then it will form a cycle. And we can only add the edges if they do not form a cycle. Okay, do not form a cycle. So next let's see, can we pick up DF? Can we pick it up? If we put DF here, this is going to create a cycle. So we cannot pick up DF. No, we cannot pick up DF. Then let's look at BD. Can we pick up BD? If we put BD here, then again it's forming a cycle between these 4 vertices. So we also are not going to pick up BD. After this, let's look at AB. So can we put AB here? Yes, we can put AB here because it is not forming a cycle. Okay. Now the last edge which is left is AC. Can we put AC here? If we put AC here, then this forms a cycle between A, B and C. So we cannot select and put AC into the minimum spanning tree. So now since we have connected all the vertices, so this is our minimum spanning tree that has been formed from the given graph, which is this one, using the Kruskal's algorithm. Is it clear to all? Now if you want to find out the cost, it will be same as that we have seen in the Prims, which is AB plus weight of BC plus weight of CE plus weight of ED plus weight of EF. So it's going to be 7 plus 3 plus 3 plus 2 plus 2, which is equal to 17. I hope this algorithm is clear to you all. For any doubts or any more further questions, please put them up in the comments section. Thank you.